Greetings, welcome to today's class. In today's class, we will begin to learn Module 4, which comprises of topics called as superchargers and turbochargers, as well as about fuels. So, this is a part of fourth module, where the supercharger and the turbochargers as a part of a fourth module, which consists of fuel supply system for SI and CI engines also. So we will be learning supercharger and turbochargers, along with that naturally aspirated engines, forced induction, different types of superchargers, turbocharger construction and operation, intercooler and turbocharger lag. So these are the topics we will be learning in this particular class. When I talk about the naturally aspirated engines, it means that uh, it's an IC engine in which air intake depends solely on atmospheric pressure. In naturally aspirated engines, air or air fuel mixture is drawn into the engine cylinders by atmospheric pressure acting against partial vacuum that occur at the piston when the piston travels downwards. So when the piston moves towards the bottom dead center, it creates a partial vacuum. That partial vacuum is filled against the atmospheric pressure by the incoming air fuel mixture or the air inside the cylinder. So because of the restriction, the engine inlet a small pressure drop. As a result, volumetric efficiency will reduce. The density of charge decides the power output of this engine. As we talk about this, when we talk about a forced induction is a process of delivering the compressed air into the intake of the IC engine. A forced induction engine uses a compressor to increase the pressure, temperature and the density of the air. So before letting the air into the cylinder, the air is compressed, the pressure is increased, and the density of the air also increases obviously when the pressure is increased. That air is forced into the engine. So that category of the induction is called as a forced induction. Okay. So we try to we try to talk about the supercharger and turbocharger. But prior to that, we will learn what is the need for this. To learn about what is the need for this, the aim of an engine designer is to achieve improved power output with the minimum emissions. That would be a primary aim of an engine designer. The power developed by a naturally aspirated engine usually depends upon the amount of air inducted into the cylinder, extent of utilization of the induced air, the speed of the engine, quantity of the fuel admitted and its combustion characteristics, and finally the thermal efficiency of the engine. So in order to increase the power, we have to work on all these 5 parameters which we talk about a naturally aspirated engines. So we recall about the brake power developed in a 4-stroke engine. So when we observe, as we can observe from this expression, that indicated mean effective pressure depends on the pressure inside the combustion chamber at the start of the combustion or at the start of the cycle. That's a power cycle. So if you want to increase the mean effective pressure, one way is doing, if you want to increase the power output of the brake power output of the engine, one way is that increasing the pressure. So if we increase the value of the pressure, obviously the mean effective pressure will be increased. And that could lead to an increased power output from the engine. So we can see the expression that brake power is given as an constant multiplied by the mean effective pressure versus the swept volume into N by 2, where N stands for the speed. So if you want to increase the brake power, I have to increase the mean effective pressure, or I have to increase the speed of the engine. So now the question becomes how we increase the value of the pressure, and that is where the concept of superchargers comes into play. So recalling the engine brake power output equation, you know that it's a constant multiplied by the mean effective pressure by the displacement volume multiplied by the half the speed, where N stands the number of revolutions of the crankshaft. So why we are doing I mean half n by 2 in our is that in one cycle for every 2 revolutions the crankshaft rotates 2 revolutions, right, for 4-stroke engine, right. That's what we take it as a n by 2. We can immediately observe that we can increase the brake power through the choice, I mean to the two choice, that is increasing the mean effective pressure or increasing the speed of the engine. So the alternative available, right, is to increase the brake power output, right. That's one way. We can observe that increase in brake power, brake mean effective pressure would essentially involve increasing the pressure at which the air or the air fuel mixture is introduced into the combustion chamber. So if we can increase the intake pressure, that is a pressure at which air or the air fuel mixture is introduced into the combustion chamber, we could increase the brake mean effective pressure as we just discussed. Am I right? So this process of increasing the mean effective pressure with the help of increased air inlet pressure is called as supercharging, or you can like this. This process is called as a supercharging, and the device which is used for achieving the same is called as a supercharger. So what do you talk about? We usually we are talking about the device, right? Supercharging as a device, right? So what is a supercharging process? A supercharging process is a process in which the inlet air or air fuel mixture pressure is increased, right, in order to increase the brake mean effective pressure, thereby increasing the power output of the engine, okay, without working on any other further parameters. So if I want to increase the speed, I can go on increase the speed. The second option is for me. So primary option is increasing the brake mean effective pressure, right. So supercharging, as I talked about, the process of making sure that the air or the air fuel mixture introduced into the combustion chamber at the pressure higher than the atmospheric. Those engines are called as supercharged engines, and the device which does the function is called as a supercharger, as I talked about it. So it is achieved by supplying air or air fuel mixture at pressure higher than the atmospheric pressure. So the increase in the air density enhances the mass of the air of the fuel mixture is also increased. The sweat volume is increased. Therefore, power output is increased. We'll talk about these things later. That gives us a very clear picture about these particular points, right? So uh, let us look at what are the benefits we get out of supercharging. So what is the advantage of supercharging that particular engine? So when I talk about the benefits, the following are the benefits what we get, right? Increasing the pressure at which the air is taken into the cylinder, the density of air increases and the pressure in the air also increases. If the density of air increases, we can immediately observe that for the same volume would have increased the mass of air if the amount of air which we have taken into the cylinder is more than the previous volumetric efficiency. That means that the volumetric efficiency would increase. That is one benefit of supercharging. So when the volumetric efficiency increases, the density of the air increases, it implies that the mass of air taken into the cylinder increases. This implies that the volumetric efficiency increases, which is a beneficial for us. The volumetric efficiency of the engine would increase, means the mean effective pressure increases, which implies that power output will obviously increase. So therefore the thermal efficiency would become better. The better thermal efficiency of the engine, that adds another added advantage of an supercharging. And we can immediately observe that by supercharging we get more torque or power output for the same displacement, for the same cylinder volume, right? You get the point? We get the more power output or a torque, and uh, we can increase the power output of the engine without doing much modification in the engine itself. So remember that same cylinder size, the specific power output per unit area will be increased. In other words, the specific power output increases and we get more power output for the same engine size. Am I right? So the advantages, I can abbreviate it as a smaller one in terms of power output can be increased. I just try to put out in a bullet points. So more quantity of charge can be introduced. Better automation of the fuel will happen. Better automation. Automation is a process of breaking down the molecules, the larger sized molecules of the diesel engine, very fine particles. So you can achieve better atomization. So better mixing of air and fuel will happen. As I mentioned, so in the combustion, if it is an turbulent combustion, that could lead to an efficient combustion. So we can achieve an efficient combustion by a proper mixing of air and fuel. Better scavenging of exhaust gas is also possible. So in a petrol engine, we talked about the scavenging process. This scavenging process could be better for the exhaust gases, right? The torque is improved. I would face the same thing, right? When the power output is increased, the torque output is increased. And we are not compromising in the size, right? The size is kept same and the torque output is improved. Faster acceleration is also possible. So we can increase the acceleration also. So we come back to the limitation points. So if we increase the operating pressure, we need to ensure that the engine structure, the cylinder block, other components have made to be strengthened, right? Such that they can withstand these higher mechanical loads. Am I right? So that comes about the point that due to increased pressure. So the engine component should be capable of withstanding the higher pressure or higher pressure exerted by the cylinder components, right? So obviously that could cost the engine increase, the cost of the engine to be increased because of supercharging. Supercharging involves introduction of more components, and the cost and complexity of the engine would increase, right? These are what to say is essentially requirements that come about with the supercharging. That is, we need to ensure that the mechanical loads and the structure, mechanical load and the structures, and we have to essentially introduce more components that will increase the cost and complexity of the engine. So detonation tendency is also high, right? So we are increasing the pressure. As the pressure increases, the detonation tendency is also increased. Heat losses due to the turbulence is also possible. Better lubrication is required. As we elevate to a higher temperature, we have to manage with a proper lubrication system to have a better lubricating properties. So the lubricating oil could lose its property, right? So we have to have a mechanism to have a proper lubrication at elevated temperatures also. So, and better cooling is also required. We have to manage with a better cooling system. That better cooling system means we have to couple with some additional components to have better cooling system. So thereby all these points, when the detonation is increased, when the turbulence is more, when the lubrication component is to be improvised, when the cooling system to be improvised, it could obviously increase the cost and the complexity of the engine. So this is the limitation part of this supercharger. So summarizing to an important points, supercharging increases the power output of the engine. It does not increase the fuel consumption per brake kilowatt hour. A portion of the engine power is utilized for compressing the air, resulting in some power loss. So this we will talk about later. The overall increase in the power have exceeded for naturally aspirated engine. The engine should be designed to withstand higher forces due to supercharging. The increased value of pressure and temperature may lead to detonation. Fuel must have better anti-knock characteristics. So this is for the point we're talking about. So supercharging arrangements, right? So how the supercharging is done? What are the different arrangements we can have? The different methods are used to run a supercharger. So the following, we'll show the diagram. So some arrangements used to run the supercharger. The first arrangement, the engine drives a compressor which is coupled to it by using a step-up gearing. A part of the power developed by the engine is used to run the compressor, and the compressor supercharges the engine. So it means that supercharging of an engine by a compressor, where the compressor is run by the part of the power is generated from the engine. So we have got the engine. So we have got the engine where the power produced from the engine, the part of the power is produced from the engine is taken by uh, the gas, so that supply that powers and compressor. The atmospheric air is taken to a compressor, and the compressor compresses the air, and this compressed air is given to an inlet. So here this process of supercharging, that is increasing the pressure of the air, is done with the help of an compressor that is run by the part of the power given from the engine itself. This is the first arrangement we can see. So when you talk about the component, the first component is inlet, second component is the output of the compressor, the third point is that after the cooler, we give it to the engine. From the exhaust, we give out the exhaust to the atmosphere. So in another method, a turbine coupled to a compressor is driven by engine exhaust itself. So in the previous case, what had happened is the turbine, the compressor was driven by the engine itself. Engine, the part of the power from the engine itself. But here we have a method where we can have a turbine that is coupled to a compressor, and this turbine is driven by an engine exhaust. The turbine used in this arrangement is free from the engine, except of the exhaust pipe and the air pipe. The power output of the engine is not used to run the compressor. This is called a turbocharging. It's an arrangement which is called a turbocharging arrangement. Turbocharging itself is a part of a supercharging arrangement. We have to see that in a detailed manner in the upcoming slides. Right? This is the arrangement what we have for a turbocharging mechanism. In the third method, all the components, that is engine, turbine and compressor, are coupled together with the gearing. The part load, turbine develops less power which is insufficient to run the compressor. In case the engine supplies additional power to compensate the less power of the turbine, if the turbine is developing more power to run the compressor, it is supplied to the engine itself. This is a supercharging engine, turbine, compressor being coupled together. So in this method, what is happening? A part of the energy is used to turn the turbine itself. So the turbine runs the compressor, and the compressor is utilized to run the engine. As we mentioned, if excess power is developed by this turbine itself, that would be directly coupled with the help of gear to an engine to give up more power. This is a one type of arrangement. So the fourth arrangement, the final arrangement, the total power of the engine is utilized to run the compressor, and the exhaust gas from the engine drives the turbine to power the power output. Such arrangement is called as a free piston engine. Sometimes electric motor drives the compressor independently. So this is the fourth arrangement where we have got the total power of the engine is used to run the compressor only, and the exhaust gases from the engine drives the turbine to give the power output. So it's an arrangement what we have done. It's a different arrangement what we have done. Right? The entire engine is dedicated to run the compressor itself. So rather after the inlet air that is passed to an engine, it produces exhaust gas. That exhaust gas runs a turbine. So that turbine gives the required energy, required power output to the as a load requirements. Here the concept of supercharging is taking over to give more power, high pressure air or air fuel mixture into the engine, which produces exhaust gas. That exhaust gas is utilized for running the turbine. So that turbine will produce the power and gives the required load. So we have talked about the turbine size, right? As we said, so we can simply generally classify them into two categories, right? One is the mechanically drive superchargers, or mechanically driven superchargers, or turbochargers. So what is basically turbocharger is a part of supercharger, right? So hope we encounter this term already, turbocharger, in practice more frequently, right? So mechanically driven supercharger is one where the supercharger is driven by the engine crankshaft. So when the turbocharger, supercharger takes the power or absorbs the power from the crankshaft and runs the compressor, it's called as a mechanically driven supercharger. So when it doesn't depend upon the power, it's called as a turbocharger. Please note that like if you must compress the air or increase the pressure, I need to impart some energy to it, right? The energy come from some place. Now the question becomes that that if I use the energy which is available to the crankshaft output to power my supercharger, that supercharger is what is called as a mechanically driven supercharger. If you use a mechanically driven supercharger, the crankshaft would be driving the device. Energy is taken out from the engine output for the purpose of obviously limiting the supercharger. That's what we're going to spend energy right to pressurize the air. The useful energy which is available at the engine, the crankshaft output is provided into the input to the supercharger to pressurize the air which is taken into the engine itself. So types of supercharger is reciprocating compressor is used, displacement type is used, rotary blowers is used, centrifugal compressors are also used to supercharge the engine for various applications. If the engine crankshaft drives supercharger, then it is called as a mechanical supercharger. If the supercharger is driven by a gas turbine which runs on exhaust gas of the engine, it's called as a turbocharger. At this point, you have to clearly understand that turbocharger is a type of a supercharger mechanism. Right? I hope it makes clear sense. So there are three types of supercharger. One is centrifugal type, roots type, vane type. So in a centrifugal type supercharger, I hope you find this figure where it's just like to a centrifugal compressor where the air is given to the inlet air passes to the vanes. When it passes to the vanes and passes to the diffuser, its pressure is increased. As it increases, this casing is called as a volute casing. Using the impeller, the air is taken inside, pressurized. That high pressure air comes out as a compressed air output. Right? So this is a centrifugal type supercharger. So in this type of supercharger is usually mostly used in the automotive engine. It consists of an impeller made up of alloy steel and rotates at high speed, usually 80,000 rpm. Inside the closely fitted casing, the air enters axially from the center of the impeller and radial reflects at an 90 degrees. Due to the centrifugal action, the high velocity air from tip of the radial vanes is passed to a diffuser or volute where air pressure increases and then high pressure air is supplied to the engine. Due to the entry of high pressure air, 30% more air and fuel mixture can be forced into the combustion chamber. It's a roots blower. It's it consists of an inlet portion, outlet portion with an elliptical housing, which consists of an elliptoid rotors. So we can see this images that could make a bit clear. So we have to remember this diagram as we make use of these particular things for exam point of view. Okay, so this is what, right? The third one is an post displacement rotary type charger. It consists of cylindrical casing, a rotor, 4 slots, remaining contact casing, at least 1 point in the type. The rotor is essentially mounted on vane slides out of the rotor slots radially. The air is induced in the space between the blades, due to which the outward movement of the vanes which increases the space between the blades. When the space reduces near the outlet of the supercharger, it discharges air. The space between the inner surface of the body and the drum decreases the inlet outlet part. The air which enters the inlet part decreases the volume and the pressure of the air increases. So the I mean, a mechanically driven supercharger, it's a type of an supercharger, right? So we will see uh, the turbocharging mechanism. So this let us know how the turbocharger works, and then we will discuss about the aspect of it. Right? In a just broad schematic, just broad part, actually we will explain about how the turbocharger can function. Right? So if a gas turbine runs on exhaust gas of the engine, drives the supercharger, it is called as a turbocharger. So there is no mechanical linkage between the engine and the supercharger. So nearly 35 to 40% of the heat energy supplied to the engine goes into the exhaust and will be wasted. A part of this energy could be utilized to drive the gas turbine, which in turn runs the compressor and hence results in supply of more air to the engine. This boosts the engine power and increases thermal efficiency. In order to supply sufficient energy to the turbocharger, exhaust valve timing is advanced. The loss in piston work is compensated by better charging and scavenging process. So this is a schematic representing the turbocharger, where we have got a cylinder with an inlet and exhaust portion. So there is an turbine that drives the compressor. The turbine is driven by the exhaust gas. You can see this diagram. Turbine driven by exhaust gas. This driving turbine helps in powering the compressor that could compress the incoming air fuel mixture or air inside the engine. So they can see a more clear diagram that can indicate this. It usually consists of an housing, a turbine shaft, turbine wheel, compressor housing, compressor wheel and bearing housing. So this is a part. So from the engine, when the exhaust valve opens, the exhaust gases are produced. The burned gas from the exhaust manifold is passed into a turbocharger inlet. The turbocharger inlet, it consists of a turbine housing, turbine shaft, turbine wheel, compressor housing, compressor wheel and a bearing housing. So when the engine is running, the hot exhaust gas leaving the exhaust valve enters into the exhaust manifold and are directed to the turbine housing. In the turbine housing, the hot gases strike the fins or the blades of the turbine wheel and make it to rotate. As it rotates, it drives the shaft. This driving shaft will compress the atmospheric air coming inside to it. This compressed atmospheric air or hot and pressurized air is passed to an engine after cooling, and it just gives a high pressure air into the engine. This is the part how the turbocharger is going to work. A turbo shaft connects a turbine wheel, as we talked about the same thing. So we can observe that once we pressurize the air into the turbocharger, its pressure increases, but temperature also increases, right? Once we compress the air, you know, we look at a reservoir of compressed air and store it in a reservoir. The air gets pressurized, but the temperature increases. If we supply that air at high pressure and high temperature directly to the engine, what will happen? The pressurized air, the density will increase, but simultaneously increase in the temperature. The increasing in the density will not be significantly right. Significant, right? Significantly right. Therefore, we will trade off. We will just try to reduce the temperature and give the low temperature air, right? The point is that we want to increase the density only, right? Density of the air should be increased. When the temperature, high temperature is there, the density would obviously keep on reducing. So in order to trade off the reduction in the density of the air, we will remove the heat from the engine. That's why you find an intercooler in between them, right? So the increase in the density may not be the level that we want to. If we increase the density is not significant, so volumetric efficiency would be reduced, right? So what to do that? The mass of air for the same displacement volume is more, that could increase the volumetric efficiency of the engine. So that is why it is called as intercooler. The intercooler is utilized in order to cool the air and increase the density of the air and pass it to an engine, right? The centrifugal force throws the air outward. This causes the air to flow out a turbocharger and a pressure, right? The turbocharger reduces the smoke of the engine considerably, right? This is what it is. So it's a so when I talk about the turbocharger, when I try to come back to all the points what we are talking about. So first we talked about a supercharger. The later we talked about and turbocharger. So supercharger, the basic point is we will increase the mean effective pressure of the engine uh, by increasing the air pressure that is given inside the engine, or given air pressure, or even and the air fuel mixture pressure also, right? So we saw the four types of supercharging mechanism. In the four types of supercharging mechanism, turbocharging is a part of it. So the specific difference is that the turbocharger does not require the power, the part of the energy that is developed from an IC engine. So turbocharging is a concept where we will do the supercharging process with the help of a turbine. which runs independently on the exhaust gas from the IC engine. Therefore, it is called as a turbocharging. So the word turbocharging here signifies that it runs on a turbine that is powered by the exhaust gas of an engine. And once again I repeat it, turbocharging is a form of supercharging mechanism. Supercharging is simply, super means it's increasing the pressure of the air, right? So that is what the point, that is the point of it. So it's a diagram, a final diagram indicates the turbocharging of a V engine here. So you can see that there is a V engine that runs that provides the power. The exhaust gas is taken through an exhaust manifold. This exhaust manifold, the exhaust manifold is utilized to run a turbine. So when it runs a turbine, so it compresses, it runs a compressor on the other part. There are two ways. Right? When it compresses the air from the atmosphere, and we reduce the temperature, right? We need an intercooler or intermediate cooler or an after cooler. What is the need for intercooler? So we have to increase the density of the air. So when I increase the density of the air, obviously there will be increase the temperature also. The increased temperature would sacrifice the increment in the density of the air. So I have to reduce temperature so that I get an compressed air which has got higher density. This high density air is passed into the engine to have better, more output, produce more output from the engine. So in the subsequent classes, we will talk about the other topics called as fuel or fuel types of the fuel what we use and fuel supply system to the engine. So this is a part of the module 4 where we discuss about the supercharger and then turbocharger mechanism. So we will meet again in another class. Thank you.